Hi everyone, welcome to JavaTechie. In the last tutorial, we just discussed the basic introduction of Kubernetes, right? Where you understand what is Kubernetes and why we need it in the microservice world. So now let's move one step ahead and deep dive into components of Kubernetes. Before we start, let me tell you, this is very important session. You must need to know each component before you start working with Kubernetes. So I would strongly suggest you to not skip this, and if you don't understand, no worries, watch it again and again until you get the complete context. Okay, so let's get started. So these are the Kubernetes components: pod, node, cluster, replication controller and replica set, service, deployment, secrets, ConfigMap and etc. Okay, so these are the Kubernetes components. I will explain each and every components. Let's begin with what is pod and node. Okay, in Kubernetes we are not interact with container directly. The containers are wrapped into a functional unit that is called pods. Okay, and a pod can have a single container or it can have multiple container inside it, and each pod associated to a single IP address. That's how one pod can talk to another pod. And there is another virtual or physical machine where all pods wrapped into it, that is called node. Okay, so a node can have a single pod or it can have a multiple pods. Okay, now again multiple node wrapped into another physical unit, that is called cluster. So cluster either can have a single node or it can have multiple node. Okay, Kubernetes cluster are comprised of one master node and a number of worker nodes. These nodes can either be a physical computers or virtual machines depending on the cluster you created. Okay, now if you'll try to understand from backward direction, we have a cluster, and inside the cluster we can have a single node or multiple nodes, and inside each node you can have a single pod or multiple pods, and inside a pod either you can have a single containers or multiple containers. Okay, so far at high level we understand what is pod, node and cluster, right? Now let's move into the next component, that is replica set. As you understand in previous slide that pods are running inside a node and each pod associated to a unique IP address. Now let's assume I have pulled database image and running that containers inside a pod. So let me name this pod as a database pod. Okay, as you know, each application always need to interact with database. But let's assume due to some memory or CPU problem, my database pod got crashed. Now how my application will handle all the traffic which is coming to these database pods, which is not running? It may lead huge cost impact to my application, isn't it? So how to overcome this? Or how can I ensure that there is no application downtime? That's where replica set component came into picture, which will act as a replica or backup of your pod. For example, let's say I created 3 replica for my database pod. When any of your pod will crash, immediately Kubernetes will bring up the new pod from replica set and it will assign a new IP to that specific pod. You can create as many replica you want for a specific pod, and these things you need to specify at the time of creating the deployment object. I will talk about deployment object in a moment. So far we understand how this replica set works, right? If there is any pods goes down or some pod got crashed, immediately it will replace a new pod with a new IP address. Now let's move into the next component, that is service. So as you know, inside a node we can have multiple pods. Let's name this pod as a front-end pod where my Angular or client application is running, and another pod I will name it as a backend pod where my server-side code or Spring Boot application is running. And each pod assigned to an unique IP address. That's how they can connect to each other, right? Front-end pod can talk to the backend pod using the IP address. Also, we understand if any pod die, then immediately replica set will bring up a new pod with new IP address. Okay, but what if this will keep going? I mean, due to some problem, pods are keep dying and replacing with new pod with new IP address. In such kind of situation, my front-end pod can connect to the backend pod because IP is keep changing, right? That's where service came into the picture. Now each pod will associate to one service, or multiple pods can group together into a single service with label and selector. I will talk about this label and selector in my future session with an example. But for now, let's assume one pod associated to one service. Okay, where service will provide an static IP and DNS name. So going forward, each pod can talk to each other using DNS name rather than using the IP address. Okay. Let's say if backend pod's down, then under the hood, replica set will replace a new backend pod. It won't impact to the frontend pod because frontend pod still can able to connect to the backend pod with service DNS name because the life cycle of pods and service completely different. That's pretty cool, isn't it? Apart from managing the service discovery role, service also play the role of load balancer where traffic coming to your pods will be handled by service. Then service will redirect to available pods based on your loads. There are different service type used in Kubernetes like cluster IP, node pod and load balancer. These services differ by how you expose your pods internally or externally and how you handle the traffic. So I am not going to deep dive types of service now. We'll understand this in our coming session with an example. So I hope you understand enough information about service component. Now let's move into the next component, which is deployment. Deployments are Kubernetes objects that are used for managing pods. You can scale your application by increasing the number of running pods, or you can update the running application using deployment object. Also, you can configure number of pods, CPU, memory, everything through this particular deployment object. If you can observe below command, kubectl create deployment, fast deployment, then docker image, then port number, and we are specifying the replicas. Okay, here we are telling to the Kubernetes that create a deployment object with name fast deployment, then pull image from local docker repository or from docker hub, and then create a active pod with 4 replica pods, which you can consider as just a blueprint or backup of your actual pods. So instead of using this command to create deployment object, you can also use the YML file, which is nothing deployment.yml file, and you can create a deployment object with that. Okay. So in an example, when we will do a Spring Boot CRUD application, I will show you how you can create the deployment object using both command prompt as well as the YML file approach. Okay. Now let's move into the next component, which is secrets and config map. First of all, both secrets and ConfigMap used to store sensitive information of your application like password, secrets key or API key. Let's say I deployed one Spring Boot CRUD application to Kubernetes. Usually we do configure our database properties in Spring Boot application.properties file or application.yml file, right? Which is not secure. If any changes done in configuration, again you need to rebuild your Docker image, then you need to deploy it to the container, which is kind of rework for a developer, isn't it? Why not we'll separately manage this sensitive info outside of our application. Since we are using containerization platform, why not we'll directly use Kubernetes component to store my sensitive information. That's where to manage secrets and configuration of your application, Kubernetes provided two components, secrets and config map. These two are placed outside of pods. So if you observe, secret and config map present outside of the pods so that inside a node if there is multiple pod, they can point to the same secret and config map. They can reuse the secrets which they configured in the secret object. Okay, and the main purpose of using two different components to store sensitive information is that where in secret you can add sensitive information with encrypted format. However, in config map it will store as a plain text. Let's say for example you are configuring your data source properties, then only the password you can configure inside the secret and rest other URL driver class name and username you can configure inside the config map object. Now let's move into the next component, which is etcd. Kubernetes used etcd as a key value database. It stores the configuration of the Kubernetes cluster inside the etcd. Also it stores all the secrets and config map data inside etcd database, and the max limit is 1 MB to store secrets. Okay, so this is what all about etcd, config map and secrets. We'll discuss more about these three components when we'll deploy a CRUD application to Kubernetes. So I believe you understand good amount of context about components of Kubernetes. So what all components we learn today, in my coming session we'll demonstrate all with real-time example. Okay, so in my next tutorial we'll understand architecture of Kubernetes. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.